Were 13 and 14. This is what 13 looked like. My recommendation to you is to just break it down into pieces. It's two fractions, so I'm going to break them up into two fractions as well as the numerator and the denominator. Looking at the top part here, do they have any common factor? Common factor is 3, right?
Yeah.
So go ahead and bring that out, and you're going to have x minus 2. There's not much I can do with that, so I'm going to leave that alone. Common factor here, 7. So 7, this would become x plus. It's multiplied, so I'm good. I don't have to do any of that flipperoo reciprocal stuff. On top, does it have a common factor? Looks like 6. And I would have x plus 2. And then 14 common factor. Yeah? X minus 2. So you can see that all the binomials are pretty much going to make 1, right? This binomial with this binomial, this one, and this one. And you're going to end up with, what is that? Actually, even before I go on, I can simplify these two and a 7. So what do we got? 9 over 49? And then I can do that, can't I? Do the 9s as well? Nah, just kidding. Don't do that. That's not right. So 9 over 49. If I did everything correctly. Everybody check my work. Again, Christian equipment. I thought you were going to be closer to me. Closer to my heart.
I'm close enough.
That's as close as we need to be. Alright, so it's a fraction. What is it? 4. No, we didn't say 4. It was 9, wasn't it? 9? 9 divide 49? Alright, cool. It was taking too long. I'm getting nervous there. Cool beans. Cool. Awesome pasta. And here's that's nice. It's not that bad. I mean, you look at it, it looks like alphabet soup. But again, just break it up into little pieces. I think we'll be good. This top part, is it a difference of cubes? Does the 64 have a cube root? It does? So here's how I would write the difference of cubes, and it would be a to the third minus, and what is the cube root of 64? 8?
Yeah.
4. 8 seems kind of big. 4. So you write 4b, and that's cubed. So I'm rewriting it this way. And let's see here. Can I rewrite this? Is that the difference of squares? Or is that a perfect square? No, huh? So that's going to stay the way it is. So a squared minus 2ab minus 15b squared. Now, do you guys remember how to see if that's a difference of, sorry, if that's a perfect square? Well, you have to take the square root of the first one, which is good, right? That's a, but is there a square root of 15? No, so it can't be that. So, no. But is it factorable, though? Two numbers that multiply to 15 add up to 7. Before I make a jump on this, is there two numbers that multiply to 15 and have a difference of negative of 2? 5 and 3, huh? So I almost jumped the gun there. So it looks like a, I'll go 5b, a, 3b, and which is going to be the negative in this case?
B.
Yeah, the 5. Good job. Coming through the door, just answering questions. Oh.
Oh, yeah.
Oh, at the door. Are they doing it at the door?
Oh, yeah. There's a huge line.
That's awesome. I like it. Okay, I know what they're doing now. They're like standing right in front of the door, right? And McKenna's there, and his clique. That's awesome. Huh? It's a tardy party. All right, cool. Looking over at the right side, Let's see if this is factorable. It's not a perfect cube because I know that 45 doesn't have a square root, right? But is there two numbers that multiply to 45 and have a difference of 4? 9, 5, and 9. So A, and we're going to go 5B, and then A, 9B. And it looks like the 9 can have to be the positive, right? Positive here, negative there. Does 36 have a square root? 6 times 6, right? So let's check if that's a... So if I go A and then 6B, if I multiply and double, am I going to get the middle number? No, so that's not a perfect square. We're going to have to try to factor it a different way. Two numbers that multiply to 36 and have a difference of 5. Four times something maybe? 9 and 4? There you go. So A, 4B, A, 9B, and it looks like the 9's have to be positive. So it looks like, there we go. Except for one piece. We haven't finished this up there, the cubes. Because we need a formula for that. Do you guys remember it? It's going to go like this. I'm going to just rewrite this up here, guys, real quick. That is A to the third minus 4B to the third. It's because I don't want to write this again, and if I do, it'll be way too low. So let me go ahead and it goes like this. It's the first one, which is A, minus the second one, which is 4B. Okay, and I'll write it here real quick. It's the first minus the first one squared, plus first times the second, plus the second one squared. So that's the formula it follows. So we are at the first one squared, so A squared. First times the second, that means A times 4B is positive 4AB. And finally, the second one squared, so 4B squared would give me 16B squared. Check that. Your thumbs up out there somewhere? Can I get some shady looks out there somewhere? All right. There we go. So let's go ahead and start simplifying. What do we got? That's a 1 right here, right? This one? With 1? What else we got? A minus 5B and this gear. So good. So it looks like we might end up with A squared plus 4AB plus 16B squared all over A plus 3B. Is the numerator factorable? Usually not. So there you go. It's not hard work, it's just a lot of work. Tedious. Your muffin cool now?
Nope.
What is that? Is that peach drink tea?
Black tea with mango.
Black tea with mango? Black tea with mango.
With mango needed no.
Yeah.
It was like you were sounded like you were questioning if it was like replying to you about it.
No.
Felt bad for
I didn't know that. Why? I was like, are you sure that's black tea? You fibber. So empathetic. Beautiful. Questions here? Any questions on any part of the homework? No. We're good to go?
I have questions.
You have questions? What's up?
Oh no, I have questions about everybody else.
She's fine. She doesn't have any questions about that.
Are you questioning live?
Some of them are questions.
Alright, cool. Then that's it.